Close your eyes for a moment and imagine a construction site. It doesn't matter which one. It could be the excavation for a building's foundation, a highway expansion, an open pit mine, or the demolition of an old structure. Now, think about the machines that populate that scene. Chances are, the image your brain automatically constructed was dominated by one specific color. Not the gray of asphalt, not the brown of churned earth, not the orange of traffic cones. Yellow. The machines are yellow. They're always yellow. And that certainty is so deep, so ingrained in how we process the world, that most people never stop to ask why. They just assume it's a law of nature, as if the color yellow and heavy machinery have been inseparable since the dawn of time. But they haven't. There was a time when the machines were a different color. There was a specific decision, made in a particular year, by people with names and faces, that visually transformed how an entire industry presents itself to the world. And that story is far more interesting than what anyone would expect to find in the deceptively simple question of why excavators are yellow. To understand how we got here, we have to go back to the early years of the 20th century, when the construction and earth-moving industry was young and still defining its own rules. The machines of that era were, for the most part, gray. A utilitarian, unassuming gray that inherited from the industrial tradition that associated work equipment with bare metallic tones or the anti-corrosion coatings of the time, which tended toward that same color palette. In some cases, red details were added, a color that then had connotations of military and precision machinery, but the dominant look of any job site at the time was gray. It was a visual landscape that communicated nothing beyond pure functionality, that didn't distinguish one machine from another at a distance, and that, in low light, fog, or dusty conditions, caused the equipment to visually merge with the environment in a way that had real consequences for worker safety. At that time, Caterpillar was already a major player in the sector. Founded in the early part of the century from the merger of two crawler tractor manufacturers, it had built its reputation on robust engineering and operational reliability. Their equipment worked. That was their main selling point, and for a long time, and it was enough. But as construction projects grew in scale and the density of machinery on job sites increased, the visibility problem of the gray equipment became more and more apparent. On a site with multiple machines operating simultaneously, on shifts that extended beyond daylight hours, the color of a piece of equipment ceased to be an aesthetic detail and became a safety variable with a direct impact on the likelihood of accidents. In 1931, Caterpillar made a decision that, at the time, it may have seemed more about marketing than engineering, but would eventually prove to have implications far beyond brand image. The company chose a specific shade of yellow, called highway yellow, and began to apply it systematically to its equipment. The choice was not arbitrary. Within the spectrum visible to the human eye, yellow is one of the colors that the visual system processes fastest and at the greatest distance, especially in low-contrast conditions like fog, fine suspended dust, or the artificial lighting of nighttime work sites. Its ability to stand out against backgrounds of earth, mud, rock, and concrete is structurally superior to the gray that had dominated until then, and its instinctive association with warning and caution, which was already being established at the time through its use in road signage, added a layer of automatic communication that anyone on a job site could process without specific training. The impact of the change was immediate and visible. Caterpillar machines on job sites were seen. They were seen from far away. They were seen in adverse light conditions, and they were seen amidst the rest of the materials and activity in the environment. Operators of other equipment could spot them. Workers on foot could anticipate their position and movement, and the side effect that no one had fully calculated beforehand was that they were also recognized. Highway yellow became Caterpillar's visual signature in a way that no advertisement could have achieved so efficiently. before the concept of corporate brand identity was a formalized discipline. Caterpillar had created something that functioned in precisely that way, a visual element so coherent and consistent that it became synonymous with the company that used it. Decades later, in 1979, Caterpillar decided to refine what it had built. The original highway yellow was a bright, a high-intensity shade that communicated urgency and visibility directly. But as time went on and the company's range of equipment grew, it began to be perceived as too jarring for the positioning Caterpillar aspired to. The company then developed Caterpillar Yellow, a slightly warmer and more nuanced shade than the original, less visually aggressive but equally effective in terms of long-distance detection. It combined with black details that added contrast and structure to the equipment's overall visual package. This new yellow conveyed something the original highway yellow didn't communicate as clearly: industrial sophistication. The sense that behind the color was a company that not only made big machines, but also thought in detail about every aspect of how those machines were presented to the world. The definitive consolidation of this visual identity came in 1989, when Caterpillar's yellow and black were formally integrated into the company's logo. That logo, with its specific proportions and characteristic color combination, became one of the most recognizable emblems in the entire global heavy industry. And Caterpillar Yellow was registered as a trademark of the brand, meaning no other company can use that exact shade on its equipment without committing a legal infringement.
It's a virtually unique case in the heavy machinery manufacturing industry. The color of a piece of equipment, protected as a registered trademark, with the same legal force as a trade name or a product design. Caterpillar didn't just invent construction yellow. It also legally ensured that specific yellow would remain theirs forever. The ripple effect that Caterpillar's success had on the rest of the industry was gradual but inevitable. Other manufacturers observed that yellow worked, that yellow machines were more visible, that buyers associated them with reliability and the visual authority Caterpillar had built, and that adopting the color was, in a sense, borrowing that perceptual equity. Komatsu, Caterpillar's main Japanese competitor on a global scale, adopted its own yellow for its equipment, distinguishable from Caterpillar Yellow by being a lighter, a brighter shade, different enough to avoid legal trouble, but similar enough to benefit from the mental association the market had already built between the color yellow and quality heavy machinery. Volvo Construction Equipment also chose yellow for much of its range, with its own proprietary shade that is part of its corporate visual identity. The list goes on, and in virtually every case, the logic is the same. Yellow was no longer just Caterpillar's choice, but the visual code for an entire industry. And any manufacturer that wanted to be perceived as part of that ecosystem of serious, capable machinery had powerful incentives to adopt it. But yellow isn't the only color that exists in the world of heavy machinery, and this is where the figures are revealing. If you analyze the color distribution in the global fleet of hydraulic excavators, which are probably the most representative type of equipment in the segment, about 77% of the equipment in operation worldwide falls within the range of yellow, or shades very close to it. It's a figure that confirms the color's hegemony, but also invites the question of what the other 23% are doing. 12% of equipment globally is in the orange and red range, and a group of colors that has its own visibility logic, and that some brands have chosen precisely to differentiate themselves from the yellow tide. Hitachi is the most emblematic example. Its equipment in a deep, vibrant orange is immediately recognizable on any job site in the world, and the brand has built part of its identity on this deliberate chromatic differentiation. 6% of equipment uses grays and whites, and a frequent choice for brands like Liebherr that have opted to convey technological precision and a connection to high-specification engineering, rather than the utilitarian ruggedness that yellow communicates. And a mere 5% of equipment in the world uses greens, blues, or other color ranges.
generally in specific markets or for particular applications where operator identity or the work environment have special requirements.
And what these numbers reveal is that the heavy machinery industry has developed a sophisticated visual language where color is not just an aesthetic issue, but a communication system that conveys information about the brand, its positioning, its application, and the philosophy of each manufacturer before the buyer has even read a single technical specification. The choice of a machine's color is a strategic decision with implications for how that equipment is perceived in the market, how it's identified on a job site, and what type of customer is drawn to it. Now we come to one of the least known aspects of this whole visual universe, which has to do not with the color chosen, but with the way that color is applied to the metal. Most people assume that heavy machinery is painted with conventional liquid paint, the same kind of process used to paint a car or a building's facade. The reality is considerably more interesting. A large portion of the components of an excavator, loader, or a bulldozer receive their finish through a process known as electrostatic powder coating. And the difference from liquid paint is not just technical, but also physical in a way that is genuinely surprising the first time it's explained. Electrostatic powder coating is not a liquid. It is exactly what its name implies: powder, a finely ground mixture of solid resins, pigments, and additives that, at rest, looks nothing like a coating material. And applied dry onto a metal surface without any prior treatment, the powder wouldn't adhere uniformly, and the result would be useless. What makes the process possible is electricity. The paint powder is electrically charged as it passes through the application gun, acquiring an electrostatic charge that turns the particles into magnets attracted to the metal surface of the component to be coated. That surface, being grounded, has an opposite polarity to the charged particles, which means the powder literally rushes onto it and adheres uniformly before any heat has been applied. The result at this stage is a metal part covered by a layer of colored powder that looks fragile, but already has the perfectly even distribution the final finish will require. The second step of the process is curing. The coated parts enter an industrial oven where they are exposed to temperatures of approximately 400 degrees Fahrenheit for the time needed for the powder's resins to melt, flow, and solidify into a continuous film, without seams, bubbles, or the runs that are the most common problem with liquid paint applied to vertical or geometrically complex surfaces. The result is a coating that, in terms of surface hardness, abrasion resistance, adhesion to the metal substrate, and corrosion resistance, far surpasses any conventional liquid paint with similar performance. For machinery operating in environments where contact with rocks, dirt, water, oil, and abrasive material is constant, and where maintaining anti-corrosion protection is not just an aesthetic issue, but a structural one, these properties have a direct practical value that fully justifies the greater complexity of the application process. At the moment a piece of construction equipment needs its coating renewed, after years of service involves a preliminary process of removing the existing paint that is as technical as its original application. The first option available is the use of chemical stripping agents, formulated with active solvents that penetrate the coating, break the bonds between the paint film and the metal substrate, and allow for its mechanical removal with simple tools after a specific contact time. And it's an effective method for localized areas or for parts with complex geometry where other methods are difficult to apply, though it requires specific safety precautions due to the nature of the chemical compounds involved. The second option, more widespread in large-scale industrial applications, is abrasive blasting, commonly known as sand blasting. Although in modern practice, metal grit or specific abrasive media are often used instead of conventional sand. And the principle is simple. High-pressure compressed air accelerates abrasive particles to speeds sufficient for their impact on the coated surface to erode and remove the existing paint. But what makes this method the preferred choice for renewing coatings on heavy machinery is not just its effectiveness in paint removal, but its simultaneous effect on the metal substrate.
The impact of the abrasive particles also removes the surface corrosion that inevitably accumulates under the paint over the years and creates a roughness profile on the metal surface that significantly improves the adhesion of the new coating layer. In a single operation, you achieve the removal of the deteriorated coating, the cleaning of the substrate, and the preparation of the surface for the new finish. It's the reason why in any serious heavy machinery, maintenance shop abrasive blasting is the standard starting point for any repainting process. And this is a good point to add a few facts about this world of color in heavy machinery that very few people know, and that shed additional light on the depth of a topic that at first glance seems trivial. The first fact worth mentioning has to do with the human perception of color under conditions of visual fatigue. Studies conducted in construction environments to evaluate the effectiveness of different colors in accident prevention have documented a phenomenon known as color fatigue. After several hours of exposure to the same dominant color in the visual field, the human visual system reduces its sensitivity to that color and begins to process it with less urgency. Yellow, unlike most colors, it maintains a relatively more stable level of visual system activation over prolonged workdays, which means its effectiveness as a warning signal does not decay as rapidly as that of other colors over an 8 or 10-hour shift. This characteristic, which was not the initial reason Caterpillar chose yellow in 1931, because research on color perception in work environments was in its infancy at that time, and has been confirmed decades later by visual ergonomic studies, and has become one of the strongest scientific arguments supporting the choice the industry made almost intuitively nearly a century ago. The second interesting fact belongs to the world of military history and connects to the origin of the colors that construction machinery used before yellow. During World War I and World War II, a significant portion of civilian heavy machinery was militarized. It either requisitioned by the armies or manufactured directly for military use. This equipment was repainted in standard military camouflage colors, muted greens, browns, and grays designed precisely to reduce the visibility of vehicles on the battlefield. When the wars ended and this equipment returned to civilian use, much of it arrived on job sites with its military colors intact, creating for years a visual mix of gray, green, and brown equipment on post-war reconstruction sites. And the contrast between this chromatic heterogeneity and the visual coherence offered by Caterpillar yellow was one of the factors that accelerated the color's adoption by other manufacturers in the years following World War II. Yellow wasn't just more visible than gray, it was more visible than everything else on the job site at the time. And the third fact has to do with an application of the color yellow on heavy machinery that occurs in conditions most people would never associate with an excavator. Construction equipment operating in underground mining environments, in tunnels, or on sites where artificial lighting is the only source of illumination, is subject to completely different visibility conditions than an open-air site. In these environments, conventional yellow loses some of its advantage because artificial lighting alters color perception in a way that makes some shades of yellow difficult to distinguish from illuminated concrete surfaces. For these specific applications, some manufacturers have developed versions of their coatings that incorporate fluorescent pigments, capable of absorbing the ultraviolet radiation present even in some artificial light sources and re-emitting it as visible light, at making the equipment literally glow with more intensity than its surroundings. The result is an amplified version of the same principle Caterpillar applied in 1931. Maximizing the equipment's visibility is theory in the specific conditions where that equipment will operate. The fourth fact is perhaps the most surprising of all, and has to do with the actual cost of paint in the heavy machinery manufacturing chain. Intuitively, and one might think that on a piece of equipment with a sale price that can exceed $1 million, the coating is a marginal cost component, almost negligible in the overall context. The reality is that the complete coating process for a large excavator, including surface preparation, application of anti-corrosion primers, application of the final color by electrostatic powder coating and oven curing, can represent between 2 and 4% of the equipment's total manufacturing cost.
On an excavator with a production cost of $500,000, that means between $10,000 and $20,000 dedicated exclusively to the painting process.
It's a figure that illustrates the extent to which the coating is not a decorative detail, but a serious technical component, with its own engineering, its own quality standards, and its own impact on the durability, residual value of the equipment. And a poorly applied coating that begins to degrade prematurely doesn't just have an aesthetic impact. It accelerates the corrosion of the metal substrate, reduces the service life of structural components, and decreases the equipment's resale value in the used machinery market. A massive market where the condition of the coating is one of the first indicators buyers use to assess a machine's maintenance history. Looking back from where we are today, it's hard not to be impressed by the trajectory of a decision made nearly a century ago in Caterpillar's workshops. What, in 1931, was likely perceived by many as a relatively minor image change, an update to the look of the equipment driven by practical visibility concerns, eventually became one of the most influential visual identity decisions in the entire history of the manufacturing industry. There is no other sector where a specific color is so absolutely identified with a product category. Construction yellow is not an arbitrary convention that is perpetuated by inertia. It is the result of decades of confirmation that the original choice was correct, that the science of visual perception backs up what a design team's intuition identified empirically, and that the visual communication this color establishes between the equipment and the environment where it operates remains as relevant today as it was when job sites had no artificial lighting or electronic signaling systems. And the next time you pass a construction site and see the yellow machines at work, you'll know that behind that color is a story of visibility, safety, brand strategy, perceptual science, and coding technology that has unfolded over nearly a century. There's a company that made a visionary decision when no one else was thinking about it, an industry that followed its lead with its own nuances, and a color that went from being the choice of a single company to becoming the universal visual language of an entire sector that literally moves the earth beneath our feet. That's the thing about the color yellow. It seems simple until you ask why.